Welcome to T1 Academy. In our last sessions, we discussed some concepts of number systems. Today we are going to learn about the number of zeros concept, and then we will see simultaneously the questions which was asked from this concept, right? We will see. Now, how we will find the number of zeros? What is this number of zeros actually mean? See, what is the number of zeros means? If there is any product, okay, after multiplying it, if I get something as answer like this, okay, after multiplying some numbers, I got a value something like this. Okay. So, the number of zeros means the zeros which are present at the rightmost. Okay. So, the number of zeros of this number is 2. We will not bother about the zeros which were present in the middle. We simply concentrate on the zeros which are present at the last. Okay. So, this is called zeros. Now, when we get 0, usually by multiplying which two numbers we get 0? We all know. While discussing the units digit concept also, we came across this one. So, when you multiply 5 with any even number, the units digit you will get 0. That means 5 and 2 will give us 1 0. Next, 5 with 4 also the units digit we get a 0. 5 with 6 we get 0. 5 with 8 we get 0. Okay, 5 with 0 obviously 0. Now, that means if you observe these numbers, in all these numbers we have 2, right? In all these numbers we have 2. That means in the given product, our concentration will be only on 5s and 2s. 5s and 2s. That means a pair of 5 and 2 will give us 1 0. A pair of 5 and 2 will give us a 0. So, we will check how many pairs of 5 and 2 are there in the given question, and then based on that we decide that how many zeros are there in that number, right? Next, for example, there is one question like this. There is a question something like this. Find the number of zeros at the end. Find the number of zeros at the end of 200 to the power of 50 plus 320 to the power of 20. Something like this. I have a question. I need to find the number of zeros at the end of these two things. First and foremost thing what you need to do is do the prime factorization for this 200 and 320 and observe what you will get. When you do prime factorization for 200s, 250s, 225s, 55s, and at the same time when you do the same thing with 320, 2 160s, 280s, 240s, 220s, 210s and 25s, right? So, now what I can write my 200 as 2 cube into 5 square whole to the power of 50 plus when it comes to 320, what I can write for the 320? 2 to the power of 6. 2 to the power of 6 into 5 to the power of 1 to the power of 20, right? When I multiply this, what I will get here? 2 to the power of 150. This is into, sorry, my mistake. Okay, into 5 to the power of 100 into 2 to the power of 120 into 5 to the power of 20. So, when you add all these things, what you will get at last? 2 to the power of 270 into 5 to the power of 120. Now, from this 2 to the power of 270 and 5 to the power of 120, how many pairs of 2 and 5 we can make? We can make only 120 pairs of 2 and 5. Okay, we should take the least power. That means simple. See here, if you have 100 left leg shoes and 120 right leg shoes, how many pairs of shoes you can make? You can make only 100. What about the remaining 20 right leg shoes? It is waste. Similarly, here also the same thing. Here you have 272s and 125s. But we can only make 120 pairs of 2 and 5. Because of that reason, here the number of zeros will become how much? 120 for us. Here the number of zeros at the end of the product is 120. Now, okay, good, really good, super. Next, We will have some concepts like this, especially based on factorials. We will have some questions based on factorials for this number of zeros concept. Then how we will find the answer for these factorials in general. Now please observe here. For example, if I ask how many zeros are there at the end of 10 factorial. 10 factorial means what you will do? 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. Right? So, we will see how many 2s and 5s are there. Actually, please observe, in every even number we will have at least 1 2, right? In every even number we will have at least 1 2. So, in 4 we will have 2 2s, in 6 we will have 1 2, in 8 we have 3 2s. But when it comes to 5, the 5 will be very less in number when compared to 2s in case of factorials. In case of factorials, we will have many number of 2s, but when it comes to 5s, we will have very limited number of 5s. So, anyway, a pair of 2 and 5 will give us 0, right? So, in case of factorials, we will not bother about 2s. We simply check how many 5s are there. Now, please observe here, how many 5s I have here? I have a 5 here and I will have a 5 here. Okay, so 2 5s are there. And the number of zeros at the end of 10 factorial will become now 2. It becomes 2. Okay, if it is 10 factorial, it is easy for us to solve it. Okay, good, superb. But if the question is some 200 factorial, then how we are going to solve this question? How we are going to solve this question? Why? Because we cannot write all the numbers from 1 to 200 and then count them. It is a hectic task for us. So, for that what we need to do is, there is a process for this. Simply divide 200 with 5 and observe the quotient. What is the quotient when you divide 200 with 5? 40. Now, try to write, make sure that this quotient is less than 5. Try to do this process until and unless you get this quotient less than 5. So, that means what I will do? I will take once again this 40 and divide it with 5. So, what is the quotient I get there? 8. Next, once again I will divide that 8 with 5. So, what is the quotient I will get here? 1. Quotient, remember I am writing all these are quotients. See, actually 8 is not exactly divisible by 5, but 5 will, 8 in 8 we will have 1 as a quotient. So, 48 and 1. Now, you got a value less than 5, right? So, stop your process here itself. So, the number of zeros in zeros in 200 factorial is 49 zeros. That means at the end of 200 factorials, we get 49 zeros. Okay, like this we need to solve. See, this process is nothing but getting the number of 5s in this. For example, if I require, in some special cases, we require to find the number of 2s also. In that cases, what we will do is very simple. How we divided with 5s, there we divide it with 2. There will be some cases where we need to check the number of 2s also based on the question. In that cases, we divide that given number with 2 until and unless you get quotient less than 2. Right? Like this we need to do. So, here the number of zeros are 5. Okay. For example, if I ask you what is the number of zeros at the end of 143 factorial. 143 factorial. As we discussed, we will have many number of 2s. We will only go to check with 5s. So, 143 by 5. What is the quotient I get when I divide 143 with 5? 28. Next, 28 by 5. What is the quotient I get here? 5. Next, 5 by 5. What is the quotient I get here? 1. So, total number, how much you will get here? 34. So, you will get 34 zeros at the end of 143 factorial. In this manner, we will find the number of zeros if the question is based on factorial. If it is a normal question, what we do is we simply write, check how many 2s and 5s are there in the given product, and whichever the power is less, we will take that as our number of zeros. Find the number of zeros at the end of 1 into 2 into 3 into 4 into 5 and so on up to 1000. What is this? This is nothing but 1000 factorial, right? 1 into 2 into 3 up to 1000 means this is nothing but 1000 factorial. So, we know in the factorials we will have many number of 2s, we will not bother about 2s, we only check for 5s. So, 1000 by 5. What is the remainder I get here? 200. So once again 200 by 5. What is the remainder do we get? 40. Next 40 by 5 quotients. 40 by 5, what is the quotient we get here? 8. Next 8 by 5, what is the quotient do we get here? 1. Less than 5, right? So we will stop our process there itself. So 240, 248, 249. 249 is the number of zeros at the end of 1000 factorials. Okay, next. Find the number of zeros at the end of 2 into 4 into 6 into 8 into and so on up to 360. Now please see here, this question is little bit different. Then how we are going to solve the question? Very simple, this question is also 2 into 4 into 6 into 8 into and so on up to 360, right? Now if you observe, all these numbers are what? Even numbers. So simply I will take 2 common. The 2 common in the sense, see here, I can write this as 2. Next what I can write here? 2 into 1. 2 I will write it as 2 into 1. 4 I can write it as 2 into 2. 6 I can write this one as 2 into 3. 8 I can write it as 2 into 4 and so on up to what I can write? 2 into 180. Right? That means total how many 2's are there for me here? 182's, right? It is starting from 1, we are reaching to 180. That means 182's are there. So directly I can take 2 to the power of 180 as common. The reason is everything is product. So now what I will be left if I take this one? 1 into 2 into 3 into 4 and so on up to 180. And so on up to 180. See here, already we have 2's many in number. So we need to check just 5's. So 1 into 2 into 3 into 4 up to 180 means it is nothing but 180 factorial. So what you will write? 180 by 5. You will get 36. Next 36 by 5. We will get quotient as 7. Next 7 by 5. What is the quotient we get here? 1. So 36 plus 8, 44. So total number of zeros here are 44. Okay. Next one. Find the number of zeros at the end of 3 into 6 into 9. What are these? Multiples of 3. Multiples of 3. How we done in the previous one? The same thing here. So what you will get here? 3 to the power of 70 if you take common. 1 into 2 into 3 into 4 up to 70 you get. So you need to find the 70 factorials number of zeros. So 70 by, okay, not only 70 factorial, yes, we need to find the 70 factorials number of zeros, 5's. Okay, what you will get here? 70 to the power of 70 divided by 5, 14. 14 divided by 5, 2. We got a value less than 5, right? So 14 plus 2, what it becomes? 16. 16. So here the number of zeros are for us 16. Next one. Find the number of zeros at the end of this one. Okay. Now please observe this one very, very carefully. So when you take 5 common here, what you get? 1 into 2 into 3 into and so on up to 21, and you will have 21 5's here. Am I correct? Previously we have done, just cross check that one. Okay, 5 to the power of 21 into 1 into 2 into 3 and so on up to 21. Now please observe this one carefully, students. Here how many 21's of 5 power, how much is there? 21 is already there. And at the same time, if I check here, 21 by 5, 4, 4, directly 4, right? No need to check, a value less than 4. So here, overall how many, what is the power of 5 I can have? This has 4, here I will get 4, 5 power 4, and here I have 5 to the power of 21. So that means 5 to the power of 25. Is our answer 5 to the power of 25 here? Are 25 zeros? No. The reason is very simple. Actually here the number of 2's are very less when compared to 5. First, in this case, please check the number of 2's also. How you will check? 21 by 2. What is the remainder you get? 10. Next, 10 by, sorry, quotient. 10 by 2, what is the quotient you get here? 5. 5 by 2. What is the quotient you get here? 2. 2 by 2. What is the quotient you get here? 1. So you got a value less than 2. So 15, 18. So total now how many do you have here? 18. You have only 18 2's, but you have 25 5's. You have 18 2s and you have 25 5s. So the number of zeros here becomes how many? Just 18. So students, please be careful. There will be some special cases like this where by observing you may think that there will be many number of 2s, but sometimes it may not happen. Okay. So please observe such type of questions and try to write the answer carefully. So your answer is 18. Find the number of zeros at, so now see here, for your better understanding, I will tell you one simple concept. There is a number something like this. And there is one more number. I am adding these two numbers. So now tell me what is the number of zeros at the end of this sum? At the end of this sum? 2 zeros only. Why? Because the number which have less number of zeros, that number will be there. Why? Because we will add in this manner. So how many zeros do you get here? Only 2. So for the least number of zeros, we will get the least number of zeros. Now same concept applies here also. See here 108 factorial plus 74 factorial. So actually the question is 108 factorial plus 74 factorial, but here we will not bother about this 108 factorial. The reason is it will have many number of zeros when compared with 74. So 74 is the least number, so we will only check the number of zeros for 74. That becomes our answer here. So 74 by 5, that is 14. 14 by 5, the answer is 2. I mean quotient is 2. So we will get the number of zeros here as 16. Answer here is 16 for us. What is the smallest number? Okay, right? With this we have solved some of the number of zeros concept. Now we will see some other two types of questions which we will see here. Find the smallest number by which 3, 4, 5, 6, 0 must be divided to obtain a perfect cube. To obtain a perfect cube. This question is also belongs to our numbers concept only. We will see this one. Now 3, 4, 5, 6, 0. I need to divide it, I need to do the prime factorization. So don't worry, do with the small numbers, that will be more convenient. 1, 7, 2, 8, 0. 8, 6, 4, 0. 4, 3, 2, 0. 2, 1, 6, 0. 1, 0, 8, 0. 540. Right? 2, 270. 2, 135. So what you will get here? 3, 45. 3, 15. 3, 5. So what is the value of this after doing the prime factorization? What we can write this number as 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Right? Next into 3 to the power of 1, 2, 3 into 5 to the power of 1. Now, in order to make it a perfect cube, there are two chances for us. Either multiply it with some other value to make it a perfect cube, that is one method, or else the second one is by dividing it with some value to get a perfect cube. So in either ways we can do the things, but our question is we need to divide it. See here, cube means what? We need to have the power as 3. That means if you have the multiples of 3 as power, then it is fine. Else we should remove that one. Okay, the excess one. So what I can write this as 2 power 6 into 2 square, right? Into 3 cube into 5 to the power of 1. Now please observe carefully here. 2 power 6 I can make it a perfect cube. 3 cube I can make it a perfect cube, but I cannot make this 2 square and 5 to the power of 1 a perfect cube. I means it may not. So to divide, right, here I need to divide. So that means if I remove these two things, then obviously my number becomes a perfect cube, right? So removing these two numbers means nothing but dividing. So you need to divide it with what? 2 square into 5 to the power of 1. 2 square is 4 and 5 to the power of 1 is 5. So you need to divide it with what? 20. You need to divide the given question with what? 20. So that number obviously becomes a perfect cube. Dividing means removing the things. Okay, next. Find the smallest number by which 2058 must be multiplied to obtain a perfect cube. See, in our previous case what they asked us to divide. In this case they are asking us to multiply. So we will see this one. 2058, as usual do the prime factorization, 1029. 1029. So 3 table, 3 3s is 9, 4 3, 343. Next 343, we know 343 is the 7 cube, but for your understanding I will write like this, right. So what I can write, this one is 2 power 1 into 3 power 1 into 7 cube. To obtain a perfect cube, right, so I should have the powers as multiples of 3. Already for 7 it is cube, so no need to worry about 7. But please observe this 2 and 3. What did they have? They have only powers as 1 and 2. So to make it a, see, if it is division, I would have simply divided this 2 into 3. But here it is multiplication, right? So to make this power 1 to 3, what I need to do? I need to multiply it with 2 square. To make this power 3 to, 1 to 3, here also the same thing, I need to multiply it with 3 square. So what you need to do here? 4 into 9, that is 36. If you multiply the given number with 36, then obviously it becomes a perfect cube. Perfect cube. So with this, mostly all the concepts of number system was finished. So please go through the things once and then solve the questions. Thank you very much.